So far, our select queries have been restricted by the fact that we've only returned results from one table at a time. We haven't been using the power of MySQL as a relational database at all, really. Let's take a look at the way we can combine tables to form complex record sets. As we can see, we have 4 tables in our sample database, and if we take a look at the makeup of these different tables, first of all the customers table, and then the orders table, you'll notice that there are 2 identical field names. Cust ID, which is customer ID, in the customers table, which is the primary key, has the same name as the customer ID or cust ID in the orders table. In another kind of database system, this might be marked as a foreign key. In MySQL, it's not. But effectively, it acts in the same way. What we're looking at is a manner of joining data from the 2 tables together so that we can pull out all the orders, for instance, that a certain customer has made. We can't do that using the simple select syntax that we've used, however, up till this point. What we need to be able to do is to join 2 tables together. A simple way of doing that is to use an inner join, which is probably the most frequently used join in SQL. And we can write that out 2 different ways. One way is to, first of all, we specify the fields that we want. So orders, customer's surname, and orders order date is all that we're going to get back from these 2 tables. Actually, let's say we get back the total of the orders as well. So that's kind of more useful data. From customers, there's 2 different ways we can spell out this particular kind of join. Now this is an inner join, so we can either say inner join explicitly to join the 2 tables, or we can simply use a comma. We're going to use a comma for now. From customers, comma orders, which tells MySQL that we're pulling data from both tables. However, when we specify an inner join like this, we need to also include a where clause so that MySQL will be able to pull out only the rows that are relevant, and also to join up the orders table to the customers table, and so that the join occurs where the customer ID is the same in both. As we can see, the data that is returned from the 2 tables doesn't need the table names in the result set. But by using the inner join, as we've done, we've been able to pull, using quite a complex join, data from 2 tables which we wouldn't have been able to get from one single table. If we take a look at some of the other tables in this database, we'll see that there is an order items table which has 2 ID columns, neither of which is a primary key. That's because this table only exists in order to join products to orders, and we haven't looked at the products table yet either. So let's take a look at that. The products contains the product ID, which is the primary key. The reason we need order items table is that many products may fall into one order, but again we may find another order containing the same products once more. So what we have in effect is a many-to-many relationship. So we need a central joining table in between them, order items in this case, to help us to bring the data together. We'll take a look at the principles behind this in a later chapter in this title.